So with the function oriented design, we have discussed the function oriented design. In the function oriented design, we have discussed with structured analysis and structured design. And coming to structured analysis and structured design, it was identified that in structured analysis we are performing functional decomposition, and in structured design we are performing modular structurization is formed. We are framing modules. What functional decomposition is? Functional decomposition is dividing the function into modules. So how we are going to represent the structured analysis is, we are taking DFD diagrams to represent the structured analysis, and then detailed design is represented with the help of the software architecture. So this is the concept that we have discussed in our earlier classes with regarding to data flow diagrams and DFD data flow diagrams and the concepts of DSD, the symbols of DFD, the various symbols of DFD, and then hierarchical model representation. What are the different symbols in DFD? That is a functional symbol, data flow symbol, data store symbol, and then the output symbol. What is the synchronous operations and asynchronous operations? So what are the two notations of DFD? Jordi notations and Sarsan notations. Among these two notations, which notation we are following is, we will be following Jordan notation. Next, coming to structured analysis performance, this is the diagram represented. That is what is the DFDs. There will be a context level DFD, and the next to context level DFD we are going to represent level 1, level 2, level 3 like this. We are going to decompose those operations. For this we have taken an example called real mean square example, and then after to this now we need to start with data dictionary. We need to represent with data dictionary. So as how we are passing the information, that is as we are representing the splitting of operations from one system, that is an operation or an operations are divided or decomposed into a number of operations. Now what we are going to identify is, now we are going to discuss about data dictionary. So in a DFD diagram, if you observe, every DFD diagram is always accompanied by a data dictionary. What data dictionary is? Data dictionary is the place where the data is stored. List of all data items appearing in a DFD. That is nothing but it is the place where we are storing all the data. It may be a variable, or it may be a composite data item, or it may be a database. So data dictionary can be a variable or a composite data item. That is, it may be a structure. Composite data item means can be a structure, or can be an object, or can be a database. So all the data names are being represented with the representation. Suppose for an example, take that for an employee we need to represent gross pay. This is how we are using. The gross pay is the variable where we are storing all the details, the salary details of the employee. So now what is the importance of data dictionary? So as the name itself indicates, data dictionary, and when we are defining, we are saying that it is the place where we are storing our data, like a variable or a composite data type or a database. So that is what its importance is. Simply it is used to store the data. So different engineers, that is whoever working with that system, can use the same data, can refer to the same data. So that is what is the importance of data dictionary is nothing but in a project, in order to store the data and in order to share the data or in order to access the data, we will be using this data dictionary. Now it provides that is what is the, this is what the importance are being represented. So in terms of the component elements, data dictionary with larger applications grows large in size. So there may be more number of data dictionary entries. That means it is not up to, suppose if we take a library management system, now how many data dictionaries we need? We need to store the details of books. For that we need book data store. So I need my next student details maintain here. For that we need to store, for that we need to have the student table. Consider it as a table, student database or books database, a table with regarding to books, a table with regarding to students, a table with regarding to librarians, a table with regarding to admin. So in a small application itself we need to maintain nearly 4 to 5 tables to store the data. So when we consider the large complex projects, then the data dictionary will be grows on sizing. So in some cases it also be a difficulty in maintaining such large volumes of data. So now coming to this, as there is the difficulty in maintaining large volumes of data, when the project size is large, it would be complicated in maintaining more number of data dictionaries. So for this, what provided is a tool has been came for handling, for representing the data dictionary with a smooth manner. So several case tools are being designed are being provided for designing the data structure and to maintain the data easily with the data structure or data dictionary. Data structure or data dictionary both refers to same. Now, what the case tool supports? Case tool provides us queries which are used in accessing or in using of the data. So for an example, how can we use the case tool is, we can, which data item affects whenever we are making a process, which data items are being not affected, like these things we will be using. So it will be facilitated. That is what we are being using is, what is the case tool that is provided for us is, for the case tool that is provided is SQL, that is RDBMS case tool that is provided in handling the data dictionary. So composite data items are defined in terms of primitive data items. That is what this is what how we are being representing the data. So now how we are been using this data dictionary is, suppose for example take a Realme software. This is all the data we need to maintain. We need to maintain numbers. So how we are maintaining valid minus numbers equals to a plus b plus c, and a is a variable with integer type input number, b is a variable, c is a variable. So ASQ is one data dictionary. Like this we are maintaining several data dictionaries. Now how to the balancing of a DFD? Balancing of a DFD means, as we are been representing context level DFD to level 1, level 2, level 3. So from moving from level 1 to level 2, there must be the continuity flow. Whatever we are representing in level 2, there must be a continuity flow to level 2, so that it should be easily understandable. If at all there is no proper representation, see this P1 to P2, P2 to P3, P3 to P1, what is, there is no representation what happening with what this P3 is communicating to. So for that what we are been representing is, see here we are been representing, so taking 3 1, so this is what level 2, level 1 to level 2. So again from level 2 to, from level 1 to we are moving to level 2. So in that case what we need to identify is, we need to identify whether the data is moving from level 1 to level 2, if such that what are the which operations are being moving to level 2, that are to be identified and that are to be maintained. Here P3, from P3 again we are dividing P3 into level 2. P3 again contains, P3 itself contains 3 operations. Those are to be separately represented. So this particular representation, this is called instead of maintaining in a complex manner, showing it in a simpler way, such that we need to balance the DFDs. That is what means, we need to represent the flow of operations. That is whatever the decomposition we are doing. In a context level we are having main operation, and now coming to level 1, level 2, that main operation is decomposed into parts. So what we need to balance, balancing DFD means, so whatever the main operation is and how many levels we are dividing that main operation, all these levels must have to carry the entire task of main operation. In such a way we need to balance the levels. So what the operations coming in level 1, from level 1 to level 2, what the operations coming from level 1 to level 2. what the operations executing in level 2 and moving from level 3. That should be neatly balanced. That is what we have been representing with a balanced DFD. And the numbering of bubbles. So as we have been decomposing an operation into a number of operations, what is the operation that comes first, from which operation to which operation the data needs to be flow, that should be marked. That is what numbering of bubbles. So for an example, consider we are taking a tic-tac-toe computer game. So in this how we are maintaining data dictionary, that we will see with the DFD diagram. That is what the data flow diagram is. First of all, human player is there. So that is suppose think ourselves we are playing a tic-tac-toe software game. So we move the icons on the board. Suppose whatever the board we are having, I think you all know about tic-tac-toe software game. That is, there will be a board of 3 rows and 3 columns. So where you need to arrange, suppose there will be 2 players. Player A has to arrange all his items in a order. So 3 rows 3 columns ఉంటాయి. సో ఆ 3 rows 3 columnsలో అన్ని ప్లేయర్ ఏ ఉన్న ఐటమ్స్ ఒక ఆర్డర్లో రావాలి. ఐదర్ ఏ రో ఆర్డర్ ఆర్ ఏ కాలమ్ ఆర్డర్ ఆర్ డయాగ్నల్ ఆర్డర్ అట్లా రావాలి. దట్ ఈస్ వాట్ టిక్-టాక్-టో గేమ్ ఈజ్. సో నౌ వాట్ వీఆర్ డూయింగ్, వీ మూవ్ ద ఎలిమెంట్స్ ఆన్ ది బోర్డ్. మనకు ఒక 3 rows 3 columnsతో బోర్డు ఇచ్చుంటారు. ఆ బోర్డులో నేను నా ఎలిమెంట్స్ని మూవ్ చేస్తాను. దెన్ వాట్ ద బోర్డ్ గివ్స్, ద బోర్డ్ డిస్ప్లేస్ ద రిజల్ట్. నేను ఎలా మూవ్ చేస్తున్నానో ఆ రిజల్ట్ నాకు డిస్ప్లే చేస్తుంది. దిస్ ఈజ్ వాట్ కంటెక్స్ట్ లెవెల్ డిఎఫ్డి. నౌ ఇన్ మూవింగ్, what are the steps we are doing in moving? We may keep in middle position, we may keep in first position, we may keep in last position. There are the number of operations that undergoes in moving. Now what we are doing is, so first the operation, what is the main operation here? Moving is the operation. Now first we have to make a valid move. So we need to make a valid move. So first we are having a game board. Now we are taking move operation, we are performing a valid move. So valid move on which we are performing, so where we are placing our data, whatever the data I am placing, I need to place in the board. That board is the data store for our items. So in that board what I am doing is, there are 2 operations for me. One is moving on the board is one operation, and then displaying the board, whatever the user moves on the board, that will be displayed. That is with the game, that is the game plan. And then next the board displays the winner. From the board, the data store, it will store the details, it will store the items of both player 1 and player 2, so that it checks whose items are in order and it displays the result. This is what level 1 DFD is. From this level 1 DFD, so what the data dictionaries we are maintaining here, one is display is the data dictionary. So what the data dictionary contains is, the display data dictionary, it stores the game and the result of the game. What is the game? Tic-tac-toe game, and plus a result. And then move is one data store which is used to take the integer, Next, board is one data store where we are having 9 integers. So 3 rows 3 columns, there will be 9 integers. So next, another data store is game. So it is the data store where all our movements are being storing, Then result, so display equals to game plus result. So that result, final result, player 1 is winner, player 2 is winner, that will be stored in the result data dictionary. So these, for a small simple tic-tac-toe game, we need to maintain these many data dictionaries. So consider, if you are taking a major project, now how many data dictionaries will be there. So that is what the case tools are being provided. Now that is this is to the end of the function oriented design. So what we have discussed with function oriented design is, we have discussed with structured analysis and structured design. So this structured analysis and structured design is of two parts, that is functional decomposition and the other one is modular structuring. So functional decomposition is represented with the data flow diagrams. So how many data flow diagrams we can represent with the context level DFD, that is level 0 DFD, context level DFD, and then level 1 to level 7, minimum 3, maximum 7. We cannot make more than 7 DFDs. So it is called 7 is called magic number. So now during the structured design we are been representing that data flow representation to a structured chart. So why we are been using DFDs is because they are simple to design and they are simple to understand. That is what with regarding to function oriented design. And in the next class we discuss and in the next session we discuss about what is object oriented. Next to function oriented is software design. In the next class we discuss with object oriented software development or object modeling using UML. We discuss about UML with regarding to object oriented development. Thank you.